Welcome, everybody, to our Tech Talk. In this Tech Talk, we're going to talk about how to manage our virtual machines and containers together using KubeVirt on a Kubernetes environment. So my name is Kevin. I will be your presenter and your host today. I've had over kind of a decade of experience with working with DevOps development, ranging anywhere from the whole requirements gathering, testing, to kind of making developer tools, to the release automation. So essentially continuous everything within Fortune 500 companies for the last little bit.
Need to learn Kubernetes quickly? Check out our free ebook with hands-on exercises you can complete on your laptop over a short break or lunch. Visit mirantis.com/learn-k0s to download now.
So what are we going to cover in today's session? We are going to look at, why do we want to run virtualization within containerization, right? Containerized environments or in Kubernetes. So what are use cases? Perhaps some of the benefits that we get out of it. We'll look at how the architecture is kind of set up, how does KubeVirt run within Kubernetes? Then we'll go through a live installation and have a look at KubeVirt in action. Okay, so before we go into the details of all this, let's have a quick look back at the whole virtualization versus containerization conversation here, right? If you look at the types of workloads that we typically run. So traditionally we have our virtual environments, which is essentially we've got our infrastructure, we've got hypervisor on top of that, and then each individual virtual machine has its whole stack of OSs, everything that is needed for the application to run, and then the actual application itself. And then containers came along where we kind of took away the OS layer on each of the individual workloads and instead packaged up just the libraries and the applications needed or the workload needed and have that run on top of the container engine. And that's brought along quite a lot of benefits as well. So when we look at the results of the stated DevOps report, companies do actually benefit from the ability to scale and move their workloads as required, which is kind of what containers facilitates, right? But the key word there is the flexibility. When you build stuff, you have to make sure it's built in a way that is infrastructure flexible or mobile, where you can actually move things around from place to place. And so then when you look at the environment now, we could see that Kubernetes has essentially become the de facto operating system, so to speak, of the cloud, and also now on-prem. Right, with the latest 2023 CNCF's annual survey gave us results saying, 84% of us are actually using or evaluating Kubernetes at this point, and with 66% of those actually using Kubernetes in production. So it is quite a large number, and it is being commoditized to a place where you kind of don't think about it, right? We want to get Kubernetes to a place where it actually runs underneath just as an enabling layer and want to kind of forget about it. The issue with that is, even though Kubernetes is everywhere, there is still quite a lot of flavors there. So one thing one to perhaps think about is how we could actually manage all those in one single place, right? And that's a pretty long amble of just kind of saying, Kubernetes is pretty much everywhere. It is pretty much widely adopted and is running most of the infrastructure on which the cloud is working with. But with that, how about the virtualized workloads, right? There is still need for those virtualized workloads. And of course, with any greenfield application, it's relatively straightforward. You develop the workload in a more containerized fashion, but there are those that are already in place that we've used for years and years and decades, and it's just how do we handle those, right? And there is an effort to modernize virtualized workloads. I've worked with a number of customers to look at modernization efforts from your traditional workloads into containerization. And it is quite a process, and some may be difficult. So then cue to our real topic for today, right? What is the use case then for running virtualized workloads within Kubernetes? Well, Kubernetes is essentially everywhere. It's growing, and it's just going to keep on growing and become the fabric of cloud and our underlying infrastructures. There are going to be workloads that fall into a number of use cases or a number of categories that perhaps doesn't make sense to containerize, right? And we could probably group them into three different categories. One, more straightforward, is workloads that are not container ready. They're monolithic. They're pretty tightly coupled, or they're very stateful. And it's not very cost effective for migration. So the cost of modernizing it kind of outweighs the benefits of just, let's just quote unquote lift and shift it into an environment, right? But when you start lifting and shifting a virtual machine into a container, things go wrong. So we want to take a virtual machine and keep it as a virtual machine, right? And a lot of folks also, there are still some vendors that ship their software as a certified appliance. So you need the entire stack for that to work. So that's our first type of workload. The second one are perhaps security constraints, right? You have workloads that have strict disk isolation requirements. You want workloads that are isolated from other environments where you probably go through testing QA. If then something goes wrong, you want to contain that blast radius to just the virtual machine. Sorry, I had a fly in my room here. And then there are workloads where you may need multiple operating systems within a single environment. So a use case that I come across quite a bit are, we're using Linux mainly, but then there are still some Windows workloads that require a virtual machine. And so we still need those virtual machines present. Okay? So what happens then is we now have a containerized environment or Kubernetes environment that's running, and then we got a virtual machine environment, usually VMware or some equivalent, that is also running. And now we have two different environments that we have to manage. And we find that still operations is relatively siloed at times. So you have a containerized operations team, and then you have the virtual operations team. And then when we need to work with each other, and then there's going to be work needed to kind of do knowledge transfer, to tickets, all that kind of good stuff. So the benefits of running a virtual machine onto our containerized environment is, of course, first of all, you reduce your control plane footprint. You no longer have a containerized environment, a Kubernetes environment in your virtual environment. It's now one environment. You have one control plane that handles everything, which is Kubernetes, right? So kind of reduces the footprint and also reduces the complexity, because now you're managing everything through your Kubernetes APIs. You work with pods, you work with replica sets, you work with scaling, and so on. So you have a single set of orchestration primitives. And that also means that you can now take your virtualized workloads and then bring it into your deployment patterns that are more suitable for cloud flexible or cloud mobile type of patterns, such as GitOps and such, right? And then that gives you your orchestration all in place. So those are some of the benefits, because it kind of breaks down first of all, breaks down silos, which is the whole idea of DevOps. But it also reduces complexity, because now you don't have to work with multiple things. Context switching is the biggest productivity killer. So with that, we now have everything in one single place. So with that, then let's have a look at how we're going to get our environment set up today. So here's some of the projects that's going to be used in today's demo. First of all, the Kubernetes environment I'm using is K0s. This is our open source Kubernetes distribution, lightweight. And we've kind of taken, in case folks are not familiar with K0s, the project can be found at k0sproject.io. So, feel free to go download it, try it out, and play around with it. We've kind of made it packaged up into one single binary, which some of the other folks are doing. But also what we've done was made it, we have true control plane and worker separation, where taking all the components of the worker environment and just put that only in the worker. So your control plane only hosts the control plane components, right? And an additional project as well that's we just released pretty soon. I haven't actually put that on the slide over here. It's called Cosmotron. That's K0's Motron. It actually helps us with deploying K0s as well. So do feel free to check that out. And then, of course, the main thing that makes virtual machines work within the Kubernetes environment is KubeVirt. That's KubeVirt.io. So it brings our virtual machine capabilities into Kubernetes, and it is a CNCF incubating project. So it's been around for a bit. So let's talk about the actual installation and the steps that we're going to go through today. We're going to look at these 4 components to get a KubeVirt environment set up. So of course, number 1, we have our Kubernetes environment, which is K0s. On top of that, then once we have K0s deployed, we're going to deploy the KubeVirt operator, which then provides us all of the different concepts of a virtual machine, right? So the virtual machine definitions, the virtual machine instances, all of the components needed for running that within the containerized environment. We're then going to install virtctl, which actually helps us manage the virtual machines within the KubeVirt environment. Potentially going to install some of the libvirt clients on the worker just to check for compatibility and all that. But those are the main components that you're going to need to get a working environment with KubeVirt. The setup is going to be pretty straightforward. This is what the setup is going to be like for today. I got it on the left and I didn't label this. This is going to be my laptop that you're seeing over here. I've got Lens running on that so I can actually connect to my K0s cluster once it's going to be created. From there, I have K0s control installed. So this is a tool for K0s that actually helps you with the lifecycle management, the deployment of a cluster, upgrades, and others. So using that, I'm going to install my K0s cluster on a single controller and single worker environment. Now, this is in the AWS. One of the things you have to look out for when you're working with KubeVirt is that in production, your worker node has to be a bare metal node, because otherwise you're essentially running virtualization on top of virtualization, which can be done. You can actually do nested virtualization, or if you can't actually turn nested virtualization on your worker node, you could actually turn on emulation mode within KubeVirt. But again, both of these options are not the most ideal for production workloads. So if you're actually going to test things out, then that works. You have to go through additional setup steps. But when you're in production, it's best to have a bare metal node for your worker, just so this way you don't have the additional complexity of running virtualization inside of virtualization. So, it's inception type of thing. So once we have the Kubernetes environment up and running, then the next part is we'll go ahead and install the KubeVirt operator and all the components on top of that as well. And then once we have that environment, then we're going to have the virtctl installed on the laptop so you can actually control the virtual machines from your environment. Okay, so I've already got these components installed, so I won't show that, but I'll go through and show the installation step and the setup step, and then we'll look at putting some workloads onto that environment as well. So the first thing, said installation with K0s, we have cluster setup with virtctl. Things to look out for, you kind of need to have your servers ready and have SSH access. So K0s control actually will SSH into the machines, download K0s, and then install it, and then link up all of the controller and worker nodes. And then from there, we can also go ahead and download the config file, the kubeconfig file, and then connect to the actual cluster. Once that is up, there's two things that you will need to install for KubeVirt. So the first thing was we're going to install the KubeVirt operator and then the custom resource. So that'll then go ahead and install all the KubeVirt components. And then once you've done that, the last part of it is installing the virtctl. So virtctl, again, there are different available architectures. So I'm on an M3 Max, so this downloaded the ARM64, but then you could go ahead and download that for your environment as well. Now, by the way, everything that we're going through today is actually in a GitHub repo that I'll share later on. So if you'd like to try this out in your own time while going through the videos, you should have all the assets to do so. Once that's done, we now have everything instrumented. The last part then is running the actual virtual machine. So within KubeVirt, virtual machines are defined just like any other Kubernetes resource. So it's a YAML file with all of the different components needed, and I'll go through those files as well so you can see what they look like. And then once the VM instance is created, then it sits in there as a virtual machine instance within KubeVirt. And then we can use virtctl to go ahead and manage the actual virtual machine itself, right? So you could actually start it, connect to the virtual machine, stop it, and so on. So that all goes inside this, okay? And you basically create a new kind within your Kubernetes environment. So let's go through the actual process. What would it look like? All right, and the setup is going to be the same. Like I mentioned earlier, we've already got the entire, I've got my laptop set up already. So what I'm going to do now is we're going to go ahead and deploy the cluster, deploy the actual virtctl components, and then we'll have a look at the environment and see what the end result looks like. So first things first, deploying the actual K0s cluster. So K0s control, virtctl, uses, again, it's the definition file that actually specifies a few things, right? So the addresses for your nodes, the actual user, key for SSH access, the port, and then the role of the node. So over here, I've got a simple 2-node cluster. It's not very HA, but it's enough for demo purposes. And I'm just going to go ahead and put that into these two environments. To install, we're just going to do k0s apply. We'll put the config file here, and then I think I'm in the right folder. Yeah, yeah. Good. Okay, and I'll just do KubeVirt cluster. Yeah, we'll apply that, and it'll run through and instrument the actual cluster. Okay, over here, we're saying we could actually fetch the admin kube config using this. What I'm going to do is let's just take that file. I'm actually going to pipe it into a config file. Okay, a reason for that is the IP used for AWS is typically going to be internal. So I'm going to update it into the external IP for our controller. So I'm just going to quickly update that, do that, save it. Okay. And then I'm going to come now over to my Lens environment, which I'm going to actually do most of my work in. I've set this up, so I've got k0s KubeVirt. I'm actually live listening to the folder. So whenever I put a new config file, it'll automatically pick it up. And let's go in and have a look at the actual cluster. Okay. Good. All right. So you see over here a simple 2-node cluster. I've got my controller, and then this is the worker. So controller doesn't show up because I can't put any workloads on top of that, which is what I want. Okay. All right. I'm just going to open up the terminal here, and let's go ahead and set up KubeVirt. So a few things I want to do is to make sure I'm pointing to the latest release. So these steps, by the way, are all on the KubeVirt documentation, and I put it on the README and the Tech Talk repo as well. So the steps are there, and I'm actually following it step by step. Okay, so everything you're seeing over here is actually outlined in the README file. Okay, so we're going to get the new version. We're going to go ahead and apply the KubeVirt operator. So that's step number 2. And then once that's done, we're going to go ahead and apply the CRs, and that'll go ahead with the installation. So we look at our custom resources. KubeVirt components will start to be installed. So that'll take a little bit of time for it to come up and run. Okay. It's deploying there. You see now it's creating all the different resources, and we're just going to wait for it to come up as available. All right. There is obviously within KubeVirt on the documentation, there's a watch command that you could actually run. But over here, we'll just look at it on Lens. Once it becomes available, we'll be able to use it. While that's running as well, the other thing is the virtctl. So this is a simple, again, export version, and then do a wget of the actual virtctl binary, and then you'll be able to run it afterwards. So again, these steps are all in the documentation. Now, while this is running as well, just a few things to look out for when we're deploying this onto the environments in k0s. First thing is you want to check a few conditions within your worker environment. So namely the KVM folders needs to be accessible, right? And there may be permission issues. If you actually do run into that, it's just a matter of adding a KVM user, creating a KVM group, setting your user to that group, and then giving the group and your user access to the folder. Right? And again, these are all documented out. These are things that I ran into when I tried to install this earlier. The second thing is k0s has a slightly different kubelet path. We do need to modify that within the worker node to make sure that it's pointing to the right kubelet path for KubeVirt. Okay, and that command also is in the README on the repository, so you have that information there. So now we see it's deployed, KubeVirt is available. Let's have a look at how virtual machines look like within KubeVirt. Now, for that, I'll switch back to our Visual Studio here. And this is a virtual machine definition. Okay, so the few things over here. The kind here is the virtual machine. This is the CR that we created within KubeVirt. We give it a name, and then I just put a label in there for networking purposes. KubeVirt images are stored as a container disk. It's basically a storage option. So there are ones that are out there, but you can also build your own and then put that into your own repository. So perhaps I'll do another one later on where we actually create an actual container disk and then put it onto a repo. But for this one, we're just going to use one that's pre-built by the KubeVirt folks. The other one as well is within the virtual machine environment. We're defining our username and password within Cloud and Net. So obviously when you're doing this yourself, please do change it. Otherwise, I'll know what your username and password is. It's not going to be the safest thing in the world. Okay, but that's the main things that you want to look out for. Okay, networking is defined in here as well. Your devices, all your specs are defined within the virtual machine. And this is a virtual machine definition file. So they actually deploy the virtual machine. Now over here, I've got my run strategy as always. So basically that means once I deploy this virtual machine, it'll run automatically. So let's see what that looks like. Right? The first thing I gotta do is, let me do this. Okay, I'm just going to go to my folder really quickly in Lens. Okay, so I've got my virtual machine definitions in the VM definitions folder. So let's go there. And then we're going to apply the Ubuntu definition that I just looked at, right? So that's a matter of, that's just a normal kubectl, okay? Apply our file, Ubuntu, and then it's going to go ahead and create the virtual machine. So what that's doing now is, first of all, it created a virtual machine definition within KubeVirt. And then what it's done is using the KubeVirt controller, actually deploy a virtual machine pod with my name over here. All right, so this is our Ubuntu pod. Let's deploy another virtual machine. I've got a second virtual machine that I have available. Right, I'll call that Ubuntu 2. Everything is pretty much the same, right? And networking is the same, username, password. So I'll go ahead and deploy this one into the environment. Okay, so let's go through and go to our folder here. Okay, so this is going to be Ubuntu 2. So I'm going to do apply Ubuntu 2, and we'll go ahead and deploy that virtual machine. All right, so from here, let me just go ahead and look at my default where Ubuntu 2 is going to be deployed. All right, so it looks a little bit more healthier. Let's connect to the actual virtual machine. All right, so do virtctl console, and then the virtual machine name. Right, so I'll go into Ubuntu 2, and you see the VM is being booted up. Right, this is our familiar Ubuntu screen. Okay, log in using the default credentials and passwords. Okay, security, and so on. So from there, you could see I've got my what's basically a new VM instance, right, at Ubuntu 2. And I could actually look at, within the virtual machines, because I got it set up so that they're on the same network. Okay, in our definition over here, it's actually connected to the cluster network over here. So I could actually talk to the other machines if I need to, right? So if I look at this other machine over here, my pod IP, I could go ahead and ping it, see if that works. And then as you can see over here, if I look at my workloads, you're actually seeing both containerized workloads, which is Kubernetes up and running, Redis Insight, and also my virtual machines all running within the same environment. So I was going to look at doing the live installation, but I think instead of doing that, let's just go ahead and have a look at how the actual workloads would interact with each other. Right. So we have this setup currently that looks like this. Okay, we've got our controller, we've got a worker with the KubeVirt components inside it. Now, let's think back to why we wanted to do the virtualization in the first place. Well, there are workloads that perhaps don't make sense to virtualize, right? Such as databases and things like Redis and so on. So, let's just put that into a virtual machine, put the virtual machine into our Kubernetes cluster and run from there, right? What we have here is I've got in my other environment, I've got a Redis instance set up. And also, you know what what I'll do is let me just go ahead and set up that new Redis instance on my new virtual machine I just created. Right, this is completely empty, so let's do that live because I already got one over here, and then I got my Redis Insight. So you know what? Let's do that. So my Redis Insight is running currently within my Kubernetes environment, and here let's expose that and open it up in my browser. Right, so here we go. Okay, so this is actually connecting to my existing virtual machine. Okay, so if I look at my pods here, this is actually connecting to this virtual machine over here, right? So what I'll do is I'm going to go ahead and install Redis onto this, the new Ubuntu 2, and then hook it up to my containerized workload. Okay, this will be fun. Let's go ahead and install Redis. And again, these steps are on the Redis website, so let's do that. Give the console a little bit more space. Okay, clean up the apt-get repo, and then we're going to go ahead and install Redis. Okay, yes, let's do it. Okay, I'm going to run this in daemon set, so I'm going to go ahead and just clean a few things up, right? Now, obviously, don't do this in your environment. I'm making this wide open so that it's easier to connect. And obviously, within your environment, do the necessary security controls and all that. I'm just going to update this so I can actually connect to it from anywhere. And also, I'm just going to turn security off. Yep, good, good, good. Okay, let's restart this. All right, let's see where it's running on right now. Okay, so about 0.6379, excellent. Let's also make sure we've got to actually connect to it. So let's do a quick Redis CLI. Check this. I'm just going to add a new user here. Okay, all right, cool. So I got our super user. My password is listening on 6379. Okay, well, let's see if it works. So I'm going to go back to my instance here, and let's go ahead and add a database. Now remember, this is running on a containerized environment within the same cluster. Okay, so I'm going to add my database. Where's my pod here? Ubuntu 2, pod IP, and let's put that here. Okay, the username password is the one that I just set. So this is going to be admin. Oh, no, super user. Okay, super user. And also my password. Okay, test connection, check the username and password. Oh, whoops, that's not a good username. Super user. All right, I'll type it in, my password. All right, cool. Connection is successful. Let's go ahead and add it, right? And here's my new database. Let's go in. Completely empty because we just created it. And we could actually go in and perform whatever operations you need to do within Redis, just like that. Okay. So what we've just done is we went through and installed our Kubernetes cluster with k0s and k0s. We deployed KubeVirt onto the cluster. We've already got virtctl, but you're going to install virtctl to actually do the management of the virtual machines. And just so I can show you I'm not messing around with this and connecting to an instance that's already there. I'm going to stop this virtual machine. All right, so let's go ahead and exit out of it. And let's do virtctl stop Ubuntu 2. Okay, so that's going to go ahead and schedule my virtual machine to stop. You see the pod has been terminated, and that's my second database. All right, so now if I go back and look at my databases, this should no longer be accessible because we just taken it down. So that's pretty much it. So what we've just seen now is the execution and running a virtualized workload and containerized workload within the same environment using KubeVirt. So all of the projects and all of the things that I've created over here is listed out. So feel free to try it out for yourself. We do have all of the assets here on this GitHub repo. So if you'd like to play around with KubeVirt, feel free to try it out for yourself. The project that we use, if you'd like more information, we use k0s for our Kubernetes cluster. Cosmotron.io is not actually being used in this, but it is actually a way to deploy k0s onto whatever environment you like. This is what gives you your cloud mobility and deploys controller components as pods. So it's Kubernetes within Kubernetes. So you actually have smaller clusters deployed on demand and easy to manage. And then KubeVirt.io, which gives us the virtualization capabilities on top of Kubernetes. If you enjoyed this, we do have a number of other tech talks within mirantis.com/labs. And as I mentioned earlier, all of the assets that I went through with the lab today is on the GitHub repo. So feel free to try it out. If you'd like to connect with me for any questions, any comments, or just in general, my contact details are over here. So look forward to hearing from you and your successes on getting this running in your environment. Again, it's a pleasure to be able to share this with you. I encourage all of you to actually do try this out for yourself. It's actually quite fun to play around with this. So again, all the assets are on the GitHub repo. We do have folks that can actually help you as well if you're having issues with k0s or Cosmotron. And look forward to seeing you all in a future tech talk. Have a good day and see you later.